Hey, what's up guys? Mr. Fackenthal here. Today we're going to be talking about Chapter 6, Section 5, which is Analyzing and Sketching Graphs. Alright, so let's get to it. So the first thing is our key idea for this chapter, which is that graphs can show the relationship between quantities without using specific numbers on the axes. So let's think about it. This graph is kind of telling us a story, right? At this point, the distance is increasing over a certain amount of time, then it's constant, and then it's decreasing. Okay, so think of graphs as being pictures that tell stories. Alright, so example 1 has us analyzing graphs. There's not really any work to do here, we just have to describe and interpret what we're seeing. So the graphs show the temperatures throughout the day in two cities. The first one is Belfast, Maine, and the second one is Newport, Oregon. The first thing we want to do is describe the change in temperature in each city. So if we look at Belfast, we know that the temperature increases at the beginning of the day. We can see that as it increases here. And then the temperature begins to decrease at a faster and faster rate for the rest of the day. So at this second half of the day, it's decreasing faster and faster and faster. This is not constant because it's non-linear. It's decreasing faster and faster. Newport, on the other hand, the temperature decreases at a constant rate at the beginning of the day. We can see that here. It's constant because it's linear. Then the temperature stays the same for a while before increasing at a constant rate for the rest of the day. So it decreases constantly, stays the same, and then increases constantly as well. Then we can make three comparisons from the graphs. Three possible comparisons that we can make are that both graphs show increasing and decreasing temperatures. Both graphs are nonlinear, but the graph of the temperatures in Newport consists of three linear sections. So this whole graph together is not linear, but each section is. Whereas in this graph, none of the sections of this graph are linear. It's all nonlinear. And in Belfast, it was warmer at the end of the day than at the beginning. In Newport, it was colder at the end of the day than at the beginning. So we see in Belfast, the end of the day, the temperature was higher than it was at the beginning of the day. Even though there's no numbers, we know that this axis is increasing and this one is increasing. And then in Belfast, the temperature was warmer at the beginning of the day and then cooler at the end of the day. These are just some of the comparisons that we could make. There's a ton more. And we'll start to look at those as we do the practice problems coming up. So example 2 has us sketching graphs. Before we just analyzed and interpreted them, so they gave us a graph and we told a story. Now they're going to tell us a story and we're going to give them a graph that represents it. So to start this off, they want us to sketch a graph that represents each situation. The first one that we're going to do, a stopped subway train gains speed at a constant rate until it reaches its maximum speed. It travels at this speed for a while and then slows down at a constant rate until coming to a stop at the next station. So the first thing we need to do is, we have our graph over here. We need to draw our axes, okay? And we have to label them. So we're going to label our vertical axis speed. So this is our vertical axis. This will be, not going to fit that there. This one will be speed. And then our horizontal axis will be time. Now we need to sketch the graph. To sketch the graph, we have to break this apart into, we have to break apart the situation into different sections. So a stopped subway train gain speed at a constant rate. That's our first section that we'd have to graph. Okay? So a stopped subway train, it's stopped, which means it starts right here, starts at 0, and then it increases. It'll be an increasing line segment starting at the origin. So this is going to be constant. So this will be a straight line, a linear section, increasing, and then our next section will be until it reaches its maximum speed. It travels at this speed for a while. So it doesn't increase speed, the speed stays the same. So that is going to be a horizontal line. Oh, that wasn't a straight line. Let me use my line tool. So then it's going to be a horizontal line, just like this, for a little section of time. And then at the end, the last part of this, and then it slows down at a constant rate until coming to a stop at the next station. So this is going to be a decreasing line segment ending at the horizontal axis. So from here, we'll go straight down at a constant speed. All right, now let's try it again with example B. Okay, part B of example 2 says, as a television size increases, the price increases at an increasing rate. First thing we need to do is to draw the axis and label the vertical axis price and the horizontal axis TV size. So let's see, our vertical axis will be price, and our horizontal axis will be TV size. Alright, from here we need to sketch the graph. The price increases at an increasing rate. So the graph is nonlinear and becomes steeper and steeper as the TV size increases. So this isn't going to be a linear section. It's going to be nonlinear. So we'll say the price could start somewhere around here. It won't start at the origin because they don't give away TVs for free. So we'd have a line that looks something like this. It's going to be increasing at an increasing rate. As the TV size gets bigger, the price jumps more sharply. Alright, that's all we have for Chapter 6, Section 5, and this also ends Chapter 6 for us too. Don't forget to like and subscribe, comment below if you have any questions or bring your questions to class, and hit that little notification button to get updates on when I post new videos. Alright, take care.